Hello students, previous class we have done about the numericals of the concave lens. Now today we are considering the very important topic of the chapter, that is power of a lens. Okay, now basically power, it is denoted by capital P. Now how we can calculate the power of a lens and what is the definition of the power of a lens? We can say that the power of the lens is the ability of the lens to converge or diverge a parallel beam of light on refraction through it. Okay, it is the power of it is the ability to converge or diverge a parallel beam of light on refraction through it. Okay, and accordingly we can say that the power of the lens is the measure of ability of the convex or the concave lens. Okay, or as per the relationship we can write the definition or the formula of the power, that is the power of a lens is the reciprocal of its focal length. Okay, the reciprocal of the focal length, P equal to 1 upon F. Okay, so it is the reciprocal of the focal length. Power is the reciprocal of the focal length, and focal length, remember, it should always be in meter for the calculation of the power. Okay, so the power of the lens, we can say that it is the measure of its ability to converge or diverge a parallel beam of light on refraction through it. Okay, and the formula of the power P, it is equal to 1 upon F. So in the numerical, when it is coming, you have to calculate the F and then you substitute in this formula, you will get the power. Okay, now the next we have to study what is the SI unit of the power. SI unit of the power is diopter. Okay, you have to write down, it is the DIOP, it is TRE, it is diopter. The SI unit of the power, it is diopter, and one diopter you can define in the examination. The question will be define one diopter. So one diopter is the power of a lens whose focal length is 1 meter. Now you have to very carefully note this point, it should be in meter. Whenever the question it is coming, the power, the focal length should be considered in the meter, so that in the numerical, if the centimeter it is given, you have to convert this focal length into the meter, because after converting into the meter, then only you will get the power in the diopter, because diopter is there only when the focal length is in the meter. So what we can consider the power unit, it is the diopter, and one diopter is the power of the lens whose focal length is supposed to be 1 meter. So when you substitute 1 meter here, it would be 1, and the 1 meter here, when you are shifting this meter to the numerator part, you can write meter inverse, meter minus 1, and this meter minus 1 itself, it is considered as the diopter. Okay, so what is the meaning of one diopter? One diopter is the power of a lens whose focal length is 1 meter. Okay, and diopter, it is denoted by the capital D. Okay, this you should understand. So suppose if you have calculated the power, okay, if you are writing, suppose it is 1 by 2. So 1 by 2, when you are solving, it is 0.5. So you will write 0.5 and followed by this letter capital D. Okay, so what this letter capital D will denote? It will denote the diopter. Okay, so unit of the power, it is considered as the diopter. Okay, now according to the converging or the diverging lens, the power will be different, like it would be negative or the positive. Okay, so we can consider that the power of the converging lens is positive. Okay, what we will write? The power of a converging lens, it is positive because, okay, because the focal length is positive. The power of the diverging lens is negative because the focal length is negative. Okay, so these are the two important, okay, these are the two important points are there, which it will helpful in your numerical. Okay, if the question it is, you have to calculate the power of a diverging lens, so in that case you will consider the F to be negative. If the question come, the power of the lens of a converging lens, so converging lens means F you will consider as the positive, and when you solve the numerical converging and the diverging, if it is converging lens, your power would be considered as positive, and if it is a diverging one, then your power will be considered as the negative. Okay, so we are doing the calculation, we are doing the numerical which is based on the power, that is 1 by f. Okay, now here we are discussing one question. We have to find out the power of a concave lens of focal length 2 meter. Okay, and we know that the concave lens, it is the diverging one. Okay, so here the focal length will be considered as the negative. Okay, so f focal length you will be writing minus 2 meter. What is the role of the minus here? This is showing that it is the diverging lens, and f should be considered as the negative. So when you write the power definition, that is a 1 by f. Okay, so when you substitute the value 1 upon, this would be minus 2, so you will be getting minus 0.5 capital D. This will be your answer, and this capital D denotes here the diopter. Okay, so what we have studied today, power. What is the meaning of the power? Power is the measure of the ability either to converge or diverge the parallel beam of light on refraction through the lens. Lens basically it is of two types that we have considered, converging and diverging. Okay, the converging, the focal length would be positive, and the diverging, it would be negative. Okay, and the formula to calculate power, it is 1 by f. One thing important you have to note down here, that this f part, it should always be in meter. So if in the numerical, if this focal length it is given in the centimeter, you are supposed to convert into the meter, so that you will get the unit diopter. What is the meaning of diopter? It is the power of lens whose focal length is 1 meter. Okay, and the formula is 1 by f, unit is diopter. And two important things that you have to remember here, that the power of the converging lens, it is positive, because in the case of this converging lens, the focal length would be considered as positive. The diverging lens is considered as negative, because this focal length would be considered as the negative. So you are not supposed to write direct, you will write the formula 1 by f, but after writing this formula you have to consider that whether it is converging or diverging. Okay, so accordingly you will be using the sign convention. If it is converging, you will be taking positive. If it is diverging, you will be taking as the negative. So as per the given condition of the lens, you will use the sign convention to be used positive or negative. So like this you will be calculating the power of the lens, which is P equal to 1 upon F.